Hello, everyone. Welcome to another session of Microsoft Zero to Hero. I am Shahab, the host for tonight's session. This is another weekend and another session, and we, in a blink of an eye, the July is finished, and this is the last session of .NET July 2026. Let me share some news first before we invite our guests on the stage. So go to the microsofthero.com. There you could follow all the news and us on different platforms. And this is a community built by the community for the community, of course. And we have only one code of conduct, and that is to be respectful to each other, listen each other's opinion first. There's always something to learn from each other. So that's our motto. If you go to calendar, you could see also the upcoming events that we have. And today we will have Einar talking about event sourcing and how it could be the best friend of AI these days. So without further ado, I would like to invite Einar on the stage with us. Hi, my friend. Welcome. Einar, do you hear us? You're muted.
Hi.
Hi, welcome.
I think you were muted, maybe.
I'm not sure. Do you hear me now? I hope not. I hope I wasn't muted.
Okay, I didn't.
Okay. Oh, wait a moment. Okay. Do you hear me now?
No, I can't hear you, but that might be
But
just me.
if the people in the audience
I heard
could,
the music before, but I couldn't hear you. I can't hear you. So
okay. The other people in the audience, if you could write if I'm muted or not, because the microphone here seems.
okay. So I guess I should just introduce myself. My name is Einar. I'm. Thank you to Shahab and the Microsoft community for having me. Should I just get going, maybe?
Yeah, yeah, I don't know. Do you hear me
Now
now?
I hear you. Now I
Okay.
hear you.
I
Yeah,
don't
yeah.
know. I
So
haven't changed anything, but good.
So
That's
maybe you
good.
want to do your introduction again?
Yes. So I'm not sure if people heard us, but this is .NET July, and today we have Einar with us, and he will talk about event sourcing and AI, how it could be its best friend. We are a community built by community, and we are sharing for the community. You could follow us on LinkedIn, YouTube, and Twitter. And also, if you go to microsofthero.com on the calendar, you could see the upcoming videos, the upcoming events, and you could follow us everywhere. Yeah, then I'm removing that. Einar, stage is yours. If you want, you could share your screen and have a couple of
Yeah,
words
yeah,
with
yeah.
the audience and then jump in the topic.
Absolutely. So thank you, Shab, and thank you guys for having me. It's really cool to be in this community and talk about my favorite topic, which is event sourcing. So let me just get this show on the road and start sharing my screen,
That's also
which will
dear to my
be
heart.
good. So I guess my screen is now shared, I hope.
You're sharing the StreamYard.
Yeah. I'm sharing StreamYard. Okay.
Yes.
So okay, so I shared the wrong thing. This is what happens when you do live stuff. Allow
Yes.
to share
So
screen. Share entire screen. Right. That's better.
that's better. The power, the slides.
Yes. Excellent.
Perfect.
Okay. So I'm here to talk about the kind of the well, AI love event sourcing in a way. But before we actually get into event sourcing, we need to kind of understand where we're coming from. And if we look at the type of software we're doing right now, typically, I guess most of you, because event sourcing is not really a common thing for people to actually be doing just yet. At least that's my experience. You might have a different experience. But if we look at where we're coming from, so let's say you have like an e-commerce solution and you have like a cart like this, and you start adding items to the cart, like I want to have an organic milk, and you might want to have like something premium coffee, to that, and you might be increasing the number of items on that, and you also then start removing things from that, and you might figure out that, well, this premium coffee, that's actually too expensive, and you start looking around and you find something cheaper and you add that to the cart, and you might end up like doing, okay, I want to get rid of that premium coffee. I only want the value coffee. So what you do is like, okay, you take that out, and now you have your new cart. So in a traditional kind of CRUD way, this would end up being, okay, we have like a cart table or a Mongo collection or something like that actually had the I would say the expected result, right? So that's the thing that I want to now place in order. I want to take this to the checkout, and that's what we got. We pretty much lost all the things that we did, right? We don't have a track of what the things that led to this. We only have the result. And to kind of put it bluntly, that's what we inherited from the 70s. That was the technology we were given back in the 70s. So if you look at like SQL databases, they were established already back in the 70s as kind of under the circumstances, I would say, for the 70s, the limitations that we had then with CPU kind of and the memory and all the kind of storage, and it was optimized for that scenario of kind of limited hardware that we had back then. And what we've been doing ever since is the same basic kind of relational database and optimized for kind of storage and limitations that we don't really have anymore. And this is where event sourcing comes in and gives us a different approach to the whole thing. It's like, okay, how can we deal with this in a different way? I'm going to show all the details about event sourcing, but we need to kind of build up a story, I guess, what this is. So if you look at, when you take the word event, that has a lot of meanings to it. If you look at it in like software development, a lot of different things. So people associate events with different things. Like at the hardware level, you might have interrupt requests. They can be looked at like events, and you might have, even like in a front end kind of thing, you might have like this might be hard to read, but like in a old Win32 app, you had messages. Those can also be perceived as events. And you might have HTML events like on mouse click, on drag, on these kind of things. Those are often associated with events. And if you look at like C# even has a keyword at the same time space. And what they talk about is something that actually captures something very meaningful in the domain.
So, sorry, Einar, you mean like Eric Evans in the domain-driven design tackling the complexity?
Yeah. Development is already doing event sourcing. Not maybe in code as much, not maybe in their solutions, but they're certainly using a source control, right? So everything, if you look at a Git history, those are events. Those are things that happen to your repository, and you tend to want to have these as atomic as possible. So, and you have like a comment that explains exactly what happened in this thing, and only the changes that are cohesively put together. That's typically what you do in a repository, right? These things. So reading and writing are two different things. So this technology is even older than the 70s, right? So if you go back, this is what accountants do. This is ledgers, right? This is what we've been having since, well, whenever we started transacting money, because we were putting like, oh, we have to basically balance the books and go back and forth and know what's going in and what's going out of an account and whatnot. So this is really, really old way of thinking, but it makes sense, right? So it's a perfect audit trail of what's actually going on. And if we go, it doesn't really matter, but the point is how you structure it and how you store things and how you use it is different. From this, you typically have what we call observers. You have things that observe these different events as they go along and happen. And well, they can do things. So if you can think of it as if this happens, then I do this. So if this and that kind of scenarios. But a lot of the time, what you want to really do is create read models. So these entities, if you will, that we want to just read. So it's optimized for read. It doesn't mean we need to store those read models. We can actually just have them readily available whenever we need. But most of the time, you might want to actually be able to query them as well. So you have observers. They observe these different things, and they can use the same events for different purposes, as you can see on this example here. I have like a insights model that I use. So maybe it's a table in a database where I actually store some insights. I want to just track added and removed because I want to have some insights. I want to understand why are customers actually removing things from the cart. I want to understand that. That's something that we lost when we did the CRUD approach. We lost that information. We don't actually know why that happened or the correlation. Like, okay, they're doing this, and if you can correlate between multiple users and see a lot of users are actually taking away that premium coffee. Why is it too expensive? They can start digging into it and start getting insight. And then we have okay, obviously we need to see the cart, and that's a different thing. And you want to have different data represented from this, and the ability to actually do that from these events. That's a huge possibility that you normally don't get, and it's kind of also future proofing because you can add new observers and new read models in the future at any point in time and just twist kind of things around. And you can look at it almost like a materialized view in a way, like but optimized for your purpose. It can be in a different storage. You can think very like I want to have a search index for something. I want to use a graph database for this. I want to use SQL for this and a Mongo or a document database for this.
So if I want just
what you also do is you have these you might want to kind of communicate this to the outside world. So let's say you have a multi-service, like a microservice or something type of architecture, where you have like an outbox where you have different types of events. These events are something because you don't want to expose your internal kind of API in a way. So you create different types of events that are more idempotent to the outside world, meaning they don't have to piece together all the different things to understand what's really going on. You basically send them like almost like a DTO with all the necessarily details for that. So what you then do is
one question.
So, let me see. It's struggling a little bit here, but hang on. So you communicate this to the other systems, and you typically have an inbox for every source system. So if you look at how this looks like in a event store like this, so what you typically get is now a sequence of events. And if you look at the different events, you can see that there is different content on them. And in this case, it's like an HR system where you have your hiring person and you can set the address of people and you can promote them and they might move. So you have all the different events like employee promoted, employee moved, and employee address set, and so forth. And in addition, what you also want to capture to kind of all the properties that we're looking at, we want to have more context as well. So we want to capture when it happened, the event source ID, so basically the primary key of the thing that you're actually modifying, and you want to have correlation ID with it, and you want to capture who did it, but also more importantly, what we call causation, which is basically what are the circumstances this happened, what was the reason. So let's say it's a controller action. You basically capture what the controller action was and on which machine and all these kind of things that you want to actually capture. And that gives us a lot of data to actually start working with. And it's super useful for AI on different levels. So if you look at it from a regular machine learning model, we can now start predicting things. We can start looking at the data that is there and give better user experiences where we can actually say, oh, we see you tend to do this every Monday at 9:30, and start seeing, oh, that's an action that you as a user tend to do at 9:30. Maybe I can automate that for you, and you can present that to the user, and they can say, okay, do that. So that's an opportunity. But also, as you can see, everything is like very plain language. So you see all the different events going through here, and it's very easy to throw even an LLM at this. to actually make sense of your system. And another thing is like for visualization, is one of the things that you can do is also start thinking about how can we pivot this data? How can we start looking at it in a different way and pivot it around different concepts and like actually gain insight visually into your system? And this is something that we've been experimenting with as a kind of a pivot viewer, where you can actually go in and just pivot around different concepts and figure out what's going on. So like I did now a correlation ID, and some of them were happening at the same time, meaning from one request. So you can see why was that going on, and you can see what was the origin. So yeah, it was from this route, or it was from this seeding, and that's the causation that I was talking about. So what was the causation of it? And this is super useful to actually start learning and gaining insight into your system, to understand what the users are actually doing. In addition to that, you can also, when you have like a read model that is well defined, you can actually go and look at this type of scenario where you can actually get a time machine into your read models, where you can navigate back and forth and start seeing what's actually changing between the different versions of that read model. And you can also go in and see what were the related events that was actually associated with this. So, okay, that was the employee promoted event, and again, the promoted, but maybe there was like it was hired and had the address set. And you can also see this as a timeline for that read model and really start understanding what's going on with your different systems. And again, this is super, not only for humans, but also for AIs to actually understand your system. It's also, if you look at the debuggability of this, all of a sudden you have something that is much more powerful when it comes to debuggability. So what often is associated with this is, if you look at event sourcing, is the kind of CQRS type of pipeline, so command query responsibility segregation, where you're basically saying, oh, my commands are the things those are my intents of changing something in the system, and then you have your queries where you're actually reading. And what I just showed you basically is effectively that you have something that produces events and puts them into an event sequence, and you have something that observes that event sequence and produces a read model, and that read model is queryable. And those can be different databases. It doesn't have to be. It can be the same database, but you are given options you normally don't think of in a regular CRUD kind of fashion. And often associated with this is also, like we have implemented, is a specific part of the pipeline is like, okay, we need to protect our data. We need to only put stuff into the event store that is actually true, right? So we should need to validate. We need to have rules. We have something called constraints. So we don't want to put anything into the event sequence that shouldn't be there, because it's, as I said, it's inherently immutable, right? So it shouldn't be changed. And another thing that is often associated but it's not a requirement, is something called an aggregate root. In these days, we talk more about dynamic consistency boundaries. I would recommend not to actually think about aggregates anymore, but it's definitely one of the pieces, puzzle pieces from Eric Evans' book, the Domain-Driven Design book. But nowadays, people are much more kind of fluent. We don't really use that because it is very restrictive to the system, and it brings on other types of problems later on. So different types of observers. You have like reaction. I said if this then that. You have things like a reducer that actually takes almost like a map reduce. So you're telling it to be, okay, I'm going from this and this and this event, and I want you to reduce it to this shape, this read model. And the projection in our terms is much more a declarative thing, where we actually say declaratively that, okay, from these things, I just want you to automatically create that read model. So one of the things that I also want to kind of just briefly touch on is thinking about in slices. So if you think about LLMs, if you really want to optimize your system for LLMs and have a system that is healthily growing over time, So think of it as linearly growing and not having problems, because one of the things that you probably hear a lot about is the AI and the context windows. And context windows are a killer. And if you have to look at your entire system before, well, for it to actually do a change, that means you have a very coupled system, right? So, and that can be slower and slower over time, and also produce worse and worse results because of hallucination of the, well, when you have a big context window. So if you start breaking your software up into slices, that's when your AI just basically goes, oh, that's so nice. When we talk about slices, and you'll see how fine-grained they are when we talk about slices. But this is from event modeling, basically. So in event modeling, you have 4 types of slices. You have state change. A state change is represented by, as I said, you have a command, the intent of changing something, and the result being an event. And that is typically coming from a user interface. So you have a user interface that calls a command that produces an event. Then you have the state view, which is then something, well, a view. You have a front end that needs to show something, and what it is showing is a read model or a collection of read models, and those are produced from events. And then you have automation, which is basically, okay, I have a current state that I need to, well, do some automation on. That could be triggered on a schedule, could be triggered by another event, be triggered externally, API call, whatever. What it does is, like, I look at current state, I do some logic, and I execute a command that produces an event. Then you have a translation thing. Let's say you have like multiple modules in your system, maybe potentially microservices, or you have an external system that you're talking to. You need to translate whatever it is doing. So it gives you, like, okay, this is what happened in my system as an event. You do some logic, translate it, you execute a command, and you produce an event. And with these 4 slice types, you basically can, that's the claim, at least. You can basically create any system, right? So these represents, this is a, well, until otherwise proven, kind of represents perfectly all systems. And if you look concretely at what that actually means, it's like, okay, a command it can be represented like this. So you basically have a record, so a C# record that has properties coming in, and a handle method. And what the handle method basically returns is, in this case, the unique identifier for the thing that we're, in this case, registering an author, and then the event that it will produce or save in the event store. We have an event type, and as you can see, it's very, very simple. And we have I mentioned the constraint, which is basically a thing that runs on the event store, making sure that, in this case, the authors being registered are unique. We have a unique constraint basically going on. And if you look at the other side, the front end basically then, so when I'm saying we all the time, I'm talking about, we'll get back to it, but I'm a maintainer of an open source project, or, well, it's a open source organization called Kratos. And what we have is a bunch of different tools. And one of the things that we actually do is automatically generate front end, like TypeScript representations of whatever you do in the back end. So as you can see on the right side, you have your add author thing, and it's just a React app, and we bind directly the command. You see the register author thing .use. That's basically just a hook that we give you. So that was a state change, a state view. Very similar. You have like a read model, and you have a specific like query where you want to do, oh, I want to return all the authors. And then you have a projection that defines what you want to actually project from these events to this particular shape of read model. And again, it's on the right side, you see the listing. It's the same thing that we had with the state change. Don't want to spend too much time on this, but I think you get the idea of how simple these slices are. And when you get to this level, the context is super small. When you do want to add a slice, it's super fast, right? And if you want to do some modification to a slice, it's super fast because it doesn't need to read a lot. And the only coupling you basically have is on the event side. You basically the slice that sits, and we actually structure this with different folders. So we have like a state change slice sitting in its own folder, and on the state view side, the only coupling that you have to the other slice is basically using the event type from that other place, right? And that's the only coupling you have. So this is so the state view, you have automation, it's pretty much the same thing, same pattern. You have, like in this case, a read model where we do a passive projection because we don't need to necessarily materialize it. So we just take that as a dependency in, and we can then do our thing, and we produce another event. And this is pretty much what we did with the state change, only now that we have a read model, right? And the same goes for translation, only now that we will now react to an event, and actually, as you can see here, a react.
Einar, do you
Right?
hear me?
Yeah.
Okay, perfect. If you go back, like in the automation, it is kind of like the same as the state view, but I think like there's like a background service or background application is running, and once in a while, like checking the read model, and based on that decides whether some actions need to be triggered or not, right?
Yeah. So it can be like a scheduled job. That's the typical automation thing, but it could also be like an external call, someone deciding that, you need to do this, and then calling you, or it could also be triggered by other things, like an actual event could be triggered by a like an MQTT thing or whatever, right? Something that actually triggers you to do an automation. So you
Okay.
basically have a trigger for it, right?
So in terms of also like event storming, I think this could also be related to the policies that we were defining there, right? That were like kind of after any event is triggered, and there was a policy, and that policy, if it is true, it might trigger an action or a command. Yeah. Okay.
Yeah, definitely.
And when we go to the next slide about the translation, I assume the event, which is like kind of the entry point to this translation process, is it kind of like an external event that is happening and we want to change it to something internally, like acts as an anti-corruption layer, for example?
That's a perfect explanation of it, actually. So because that's exactly what it does, and that's its purpose, because you don't want to take a coupling to the other system directly. So you basically have this event that translates, because you don't own the events from, let's say, another microservice or a different system or a different module. You don't own those, right? That's not yours to own. So you shouldn't be just taking those events and say, I'll just append them directly to my event store. That's owned by something else, and you need to translate that into something that makes sense for your domain. So it is perfectly, as you say, it's an anti-corruption layer. That's exactly what it is, right?
Okay, and we always need to have a command in here, or is it like possible to just transform this external event to something that internally we are caring about?
Yeah, absolutely. So there's nothing kind of, this is, so from event modeling perspective, that's exactly, you could basically look at like that iReactor thing that on the top, the book reserved, that could be producing the event directly. And in many cases, that's what you want to do, because you don't want to go through the command at all. So it's perfectly fine to actually do that as well. But it's more the notion of what you're doing, really.
Perfect. Thank you so much.
Yeah, of course. So not everything in this world is greenfield, right? So that's a big challenge to kind of event sourcing. And this is often the argument is like, yeah, but we already have stuff, right? So what do we do? And well, it's fine if you start greenfield. That's the argument that we hear all the time, is like, okay, how do we start when you have a lot of software, which most people already have? And it's been a kind of a puzzle to kind of figure out how to actually do that in a way. And what we've been working on is kind of, okay, we need to be investigating, well, basically do some forensic on an existing system. So, and these days, I've talked with a lot of people, and some people actually do so. They want to modernize an existing system, and they throw an LLM at it and say, I just want the LLM to convert my code. The problem with that approach is that LLMs well, you have the context window, so that's a clear limitation, which will kind of, well, if you have a large code base, that will be a problem. So how do we chunk the code base? And that's one problem on its own. You might be able to actually do that, but I would say that the bigger problem is, at least with code bases that has survived maybe generations or even like a decade, and there's been multiple different developers at it, and you tend to not have consistency, no matter how much you tried to keep everything consistent. People come and go in organizations, and you end up with like code base that is very inconsistent. So how can you really extract the necessary things from it to understand it? So what we did is actually abandon that idea completely, and went with something completely else. It's like, okay, how can we take your packaged software and, well, do the forensics without actually looking at your code? So the way we approach this is, you already have an API, right? And what we can then start assuming is like your posts, your puts, your deletes, or whatever it is, those are commands. Your gets are queries. If we can kind of assume that, we have a very good starting point of how to do this. So the next thing is, you already have a lot of, well, you have your database schema, and you have things like you can do change data capture. So I can start looking at your data and start figuring out what is changing from this. And I forgot to mention on the API side, what we are doing is actually put a proxy using YARP, actually, yet another reverse proxy, where we actually put that in between. So all the API calls actually goes to our thing, our component, and it forwards everything down to the other component. And that means we can plug it in at runtime, basically. So all you need to do is just configure it, and it's there. And with a database, we can also do the same thing. It's like, okay, give it access to the database, and we can start looking at the data, change data capture. We can do like SQL and Postgres, and all these databases have these change streams where we can actually look at when transactions happen, and we can start looking at different changes. So with that, we can also look at like the additional metadata that is associated with commands. So think of traces. So if you look at like telemetry, open telemetry stuff, if you already have an app that is instrumented with open telemetry, we can go and look at the traces. If you, for instance, have set up automatically with like ASP.NET Core, you have automatic setup of traces for traces for the controller actions and things like this, we can capture that as well. We can then look at, and that gives us an idea of what are the things that are correlated, what's actually going on with the system. And then the last piece of the puzzle is, okay, we can also capture logs. And this gives a holistic view of what is actually going on with your system. And if you look at the database schema, if we can go and actually get the constraints there, so you, of course, you have your uniqueness constraints and things like this, but you might have other types of constraints as well. And that's part of your validation logic right there. You might have field definitions that says, okay, maximum size is whatever on a varchar, so 256 or whatever. We can start having those things, and those become rules. So all this gives us a holistic approach to actually looking at your system. So what we've come up with is a process for actually doing this backed with software. So we want to extract, so take basically we want to configure what we need to capture, and then we put that to action, and you deploy it to your system, and we start extracting that data. And we collect it. There's a couple of ways we can collect it. We can collect it to JSON files, or we can collect it to what we call a receiver that you can actually just run yourself and collect it into a database. Or we also have a managed service for this where we can actually collect it. And the next thing is we want to interpret what's actually going on and understand what does that mean. And this is also where we start using AI specifically LLMs. Actually, we have two stages. We have one stage that is very heuristic, where we can actually go in and the things that make sense, we can structure the data. We can actually group things. We can figure out what actually makes sense of that data. And then you have the unstructured things that we need to understand. And we send that off to an LLM saying, okay, with a system prompt saying, okay, make sense of this. What are extract the event types from the data that we have heuristically put together here, and give us an idea of what this system is actually doing. And then we output this to something we call a screenplay. A screenplay is then a language that we have come up with that is very domain. I would say it's almost like it's a DSL for representing applications, basically. So it's a domain-specific language for representing information systems. It's not for everything. This is for information systems. So you don't throw your games at this or whatever software you're making, right? So with that pipeline, we then have something that we're able to actually collect, interpret, and get an output that makes sense. And the way you do this is we have a CLI tool. So it's called CRUD-based, and it's this prologue thing where you can actually go and configure these different things and give it a connection string to the database. And you can set up the API stuff, where your APIs are and what you want to actually proxy, basically. And you can go in and configure your OpenTelemetry stuff. And what we'll actually do then is, okay, so we configure where you want to output these things, and then it creates a configuration file. We also have a commercial offering that is coming. It's not right now, which is called Creative Studio, which is where you can actually go and do this more graphically. So you can do a prologue from this thing, and you can go in and do basically the same thing with just a more kind of visual wizard, if you will. And you can go do the database stuff and set up the connection string in the same way, and set up your API stuff, and again, your OpenTelemetry, and
this is
finally
a very interesting.
you set up where do you want to output it? Well, I want to do the rolling JSON files, and you get a nice kind of view here where you can actually go and download the configuration, and you can also go and read how to do this and put it into your production system. So
Einar, do you hear me again?
what it actually produces is this JSON file holding all that configuration that we can then go and run on your system. And when you're kind of done that, when you've run the system, this is what it produces. Okay, this is super unreadable, but it's basically, it does capture on the top there. You'll see it captures the database transactions. So it's looking at what's actually going on, and it's seeing what's changing together, because that's important. The reason we do this, we want to figure out what are the different types of transactions you're typically doing, and that is probably the events, right? Because the properties that change together, they tend to be cohesive in a transaction. So we look at that, we capture that, and then we start looking at, okay, the API part of it. We kind of correlate these things together, and as you can see, we also have the trace IDs there, because on the last part we have the traces, so we can start seeing this holistically and see, okay, these are the things that actually happen together, and these are probably have meaning. When we know the properties that goes on them, we can and we know the table names involved, we can probably deduce the name of the event that actually happened. So from all of that, we get this Screenplay language definition. This might be hard to read for some, but it's basically instead of storing this as a JSON, we wanted to do it in a more readable fashion, not only for humans, but also for LLMs. So we came up with a language that is very, very simple, and it's actually a runnable programming language. So what this is saying is like, okay, from module invoicing, and it has a description, which also we deduce, from the whole thing. And you can have even UIs here. So, but skip the UI part. And what you have is like, okay, we have a feature, invoice management, and there's a state change for register invoice. And we have a command called register invoice, and we have the different properties. And it produces at the very end there, like it just says produces this command, this event basically. And well, there are different parts to the entire language. There are you can create these concepts, reusable concepts. You can set up GDPR things, compliance, like PII in this case, and you can do well, typical like authorization policies and things like this. And also you have like the state view part where you have like a read model and the projections and yeah, all kinds of things part of this language. This is what it ends up producing actually. And this is very nice for humans, but also for LLMs to actually work with. So what you can then do is actually do a run. So you can actually go and do create this run, and once you have this, you basically get a runnable version of what you just extracted, where you can start seeing, is this your system? And what it produces is, for instance, an API surface with all the different things you can actually see, all the different endpoints, things you have, like with the commands and queries. And you can start working with it and testing it out, right? And see, is this actually what I wanted? And what you can then do is also take this one step further with the studio part, where you can actually then import this language, this screenplay file or files, and see it visually. How does it all fit together, right? And start changing and start modifying things. And also this whole project or this product is also infused with AI all over the place, where you can actually then start working with it in a much more sensible way. So what you see on the screen is also, this is the vertical slices that I was talking about, the state changes, the state views, and the automation and the translation parts. So this is a visual tool for doing that kind of thing. So think of it as a little bit of a low-code approach. But what's also interesting about the screenplay part is that sometimes you need to do like more imperative, like I want to write C# for functionality. And you can actually do that inline in the language. So that means we're not able to actually capture your logic. You can then go in and just put in your inline, or even reference a file, C# file, and it will be included in the runtime. So it is high level, but at the same time you can do like almost like, for those of you who have been doing C and C++, there's a keyword called asm, so you can do inline assembly similar to that. So we're giving you kind of both to be able to actually do everything, right? So I realize I'm talking on on in and out. So I hope this is okay.
Do you hear me?
Strangle or integrate.
Oh.
So what I mean by that is, if you already have a system, how do you, if you have like an ambition of like, I want to, well, maybe you want to replace the entire system, or you want to integrate with it. So let's say you're making something new. So both are kind of the same in a way, with some nuances. Of course, when you're talking about strangle, you're talking about, this comes from the strangling fig pattern. I think it was Martin Fowler that actually came up with this. And if my screen, there we go. Hang on, something wrong. Some delay here.
There's some we don't see.
Oh, there we go. Very sorry about that. It's kind of lagging. So Strangler fig is an actual tree. I believe it's in Australia. I think Martin Fowler came up with the pattern as because it's a thing that takes over other plants and other trees, basically. So and that's basically what you want to do, is if you want to replace an entire system, you don't really want to do file new project because there's so much value in the existing system. It's producing business value, and it's really risky to just go and do file new project because there's a lot of knowledge in it. So what you basically want to do is like have a transitional phase where you take your legacy system and you start kind of integrating that transitional you have a transitional integration phase where you okay, I want to start maybe transitioning the data, for instance, to this other format. So you have like an integration thing that's going on, and well, capture whatever is going on the existing system, maybe even real time, and you start actually replacing parts of it till the day that you actually basically have like a new system that takes over. You can do this like gradually. You don't need to have like a big bang with a new system. You can have like a module per module, depending on how you do this. But the idea is to basically let the new system gradually take over like the old system. And that's why we call it like the Strangler fig pattern. And this approach works very well with kind of integration as well. And what we've came up with is, if you look at like a translation slice, what that could be is do a change data capture from a legacy system. So what we came up with for that Screenplay language is a thing that actually where you can describe that capturing. So in this case, this is actually pointing to an API, and it's the actual details on the configuration of the API sits somewhere else, but it's just referencing the name of that API. And it's just saying, okay, I'm going to poll this every 5 minutes, and I want you to give me all the changes that happened since then. And what this language then says is, well, I want to map from this one thing to the other. And what it actually is, so typically API doesn't return events. So this is looking at changes that change together. And it says, okay, when these properties change together, that's probably when I need to append an event. So it says append an event when that changes, or this happens, or these properties change together, or that status is happening, da da da. All these different things is basically represented in this language. And that gives you like a change data capture language that we can use for any data source that is not event sourced. And in out of the box in the open source, what we call Chronicle, the workbench part of it, we have an editor where you can actually go in and work with this, and you get kind of help on the right hand side with all the different constructs, and you can basically configure your captures, and you can then start them once they're ready. So that can also run if you're thinking about like from an integration perspective, not just the Strangler fig. If you're just integrating with like an external source, it doesn't need to be a system that you're trying to replace. But let's say you're integrating with a non-event source system, but you want to translate it into events. This could also be used for that purpose. So all that is fine. Now, let's say you have an event source system. You now have all the data that you didn't have in a CRUD system. So what do you actually do for getting insight? So what we've done is create an MCP server where you can actually go and do things like this. You can go and say, there's a typo, describe, not describe. So describe the system in the event store. And what it actually says is like, okay, we'll summarize, it will look at the events, and it will look at the different entities and different read models and all that, and actually give you a straight up answer of what this system is doing. And that is possible for us to do because we have all the different details. So what this is actually saying is actually describing all the different changes that happens to the system. It's basically saying an employee comes to life when they are hired. Yes, because of that event. And it says which properties are related to an hire, right? And the address can change, and they can move, and it looks at all these different things. And in this particular thing, we also have a customer. It's kind of a mix, and it does kind of summarize that as well. The next thing you can go and do is, okay, what are the natural next event types? Because of all the data that we're collecting, we can actually now start asking, are we covering everything in our domain? What's the gap? And it's rightfully saying, well, I can see you hire people but you don't have support for terminating people or when they resign or things like that. So, well, maybe you want to actually take a look at that. That's a natural next step. So that's something of insight that you can actually gain from this by just throwing an LLM quite easily at this, actually. The last thing that is a kind of a sample is, okay, I want to just see the data. So we have all these different events going on, but what it can actually do with this MCP is basically I can go and say, show me all the data. And what it will do is just look at the different events and create an ad hoc projection from those different events and give me the data back. And then, of course, you can start seeing that, okay, I can ask it to do whatever. I can summarize, I can do all these different things and use it as a reporting tool almost, right? And this is all just MCP for that. So that's basically what I wanted to cover in a way. It's all open source except for the studio part. That's something that we're going into beta now in August. And well, we'll see how it goes, but hopefully it'll be like a commercial offering in September from us. But everything else you've seen is just open source out there. Everything written in .NET, and except for the front end, written in TypeScript and React. And
Perfect. Do you hear me,
that's
Einar?
me out of time.
Do you hear me? Hello? Okay.
If I'm not mistaken.
No, do you hear me?
I think you're muted again.
I don't think it's on my side, I think, but the people in the audience, please again, like, confirm if you were hearing me or not. I am.
No, I heard you fine earlier, but
Okay, it seems like they're hearing both of us, but let me
oh, okay. So
let
he's
me
hearing
just
you.
join again.
Maybe it's on me then. Yeah.
I'm back. Is it? Do you hear me?
No, but the audience is hearing. But they will. If you have questions, it might be hard
Yes.
for me.
If the
So I don't know,
audience
should I
has
refresh maybe?
questions, I could bring up the questions on the screen, and Einar could answer them by.
Not if I should refresh.
I have no idea. Okay. So Einar will join us in a moment. Sorry for the inconveniences. Live sessions always like come with some problems. Do you hear me now?
Now I hear you. So it was
Okay,
on my
perfect.
side. Yeah.
All good, no worries. So you were talking about like the brownfield, and I was interested because most of the time, as you mentioned, we are dealing with like brownfield applications that we need like to do some maybe modernization. And the tools that you introduce is given that we have open telemetry, or given that we could enable like change data capture, which in most relational databases there is a way to do that. But I was also like facing applications that we couldn't. Is there any way like that we somehow being able to move data from the legacy database to the new system and also like make it like some sort of event source? And do you think that we could also make them like business related events, or would they be like more like a CRUD-based events in this scenario?
So what we've right now we've implemented like 3 or 4 different approaches to this, but we've also been looking at what's kind of interesting. If you look at all the different databases out there, if you look at like SQL and Postgres, what they do is ever seen a so you have the MDF file, right, for a SQL server. Ever seen the LDF file?
Yeah.
That's all the transactions. So one of the things that we really wanted to do, instead of doing like a change data capture, one of the things that we've been dying to do is kind of how can we access the actual log, right? I know some companies actually delete their log. no, shouldn't do that. But they do. And if you look at the nature, if you look at the architecture for SQL Server, especially, what it does is it writes to the log before it writes the actual result, right? So it writes the log, so it's actually event sourced in a way. It's actually doing capturing the changes. So if we can get to that, we can actually start seeing the things and starting to deduce it. So that's one thing. You mentioned some don't have OpenTelemetry, but you might have logging, right? So we can start looking at your logging. It doesn't need to be OpenTelemetry per se. You might have Kafka, all these different things. So what we're interested in is learning about different systems and actually implement, because it's fairly, where we are right now is fairly easy for us. Also thanks to, well, the world of LLMs to AI to actually implement new sources. So what we've done is basically implement what we needed for the work that we do. So if someone else has other things, we love to hear from you. And for your last question, what we try to not do the CRUD events. We try to not do the updated type of events. We want to get to the business events. We want to get to the true domain and business value. So that's why we work so hard on, we want to see what changes. We want to see the correlation or the properties that cohesively change together over time, together with the other metadata that we can supply it, because then we can get a holistic picture and give you a more accurate answer. It's not going to be perfect, but what you can actually then do is afterwards you can start looking at it. Okay, you got like 80% of it or 70 or whatever, and start changing.
Yeah, but I was more interested like in the architecture, like picture, like between this legacy system and the new systems, like in terms, because not every team have the capability like to go and like take a look into the details of implementation of how the LDF files are implemented, and they are mostly like on the very abstract level of working with SQL Server or Postgres, and that was like the gist of it. But thank you. That was a good clarification. Anyone, if there's any questions, we would be glad to bring it up. If not, then we are kind of at the end of the session. Just because of streaming, I'll just give it a little bit of time, like for the buffering. So thanks. Thank you for watching us. Those who joined like live on the stream, and thanks for those who are watching like later on demand. I hope you're enjoying this talk and also learn about event sourcing. It's another different approach to tackle your storage patterns, and since you are storing the whole process of what happened to your system, then it might also be interesting for data engineering, LLMs, AI world as well, as mentioned in here.
And also just reach out to me if you have any questions. Please reach out to me on whatever social media, LinkedIn, whatever, email. We also have Discord, so join us on our Discord and we can have a conversation there. Happy to answer any questions. And also, if you have input to what we've done, please, we are learning. I've been doing event sourcing since 2009, and I still don't know how to do event sourcing. So yeah.
Perfect.
Please.
Okay, great. Thank you, everyone. Wish you a very nice day, evening, or night, wherever you are on this blue planet. Have fun and see you later. Goodbye.
See ya. Bye-bye.